All right, here we have 2019 number 4. Tumbleweed, commonly found in the western United States, is the dried structure of certain plants that are blown by the wind. Cachia, a type of plant that turns into tumbleweed at the end of summer, is a problem for farmers because it takes nutrients away from soil that would otherwise go to more beneficial plants. Scientists are concerned that cachia plants are becoming resistant to the most commonly used herbicide, glyphosate. In 2014, 19.7% of 61 randomly selected cachia plants were resistant to glyphosate. In 2017, 38.5% of 52 randomly selected cachia plants were resistant to glyphosate. Do the data provide convincing statistical evidence, at the level of alpha equals 0.05, that there has been an increase in the proportion of all cachia plants that are resistant to glyphosate? Alright, so we are doing a hypothesis test here, because we are asked, is there convincing statistical evidence? We have two different samples, 2014 and 2017. And, the percent is not a dead giveaway that we're dealing with proportions, but it's pretty strongly suggestive. What we're really looking at, right, we selected 61 different cachia plants in 2014, and each of them reported a yes or a no. So we're, each individual plant is recording a yes or a no. This is categorical data, so this is proportions. So we're going to be doing a 2-proportion z-test here. But I'm getting ahead of myself. All right. Well, actually, no, because we have to figure out what we're doing before we can go through all the steps, right? We got hypothesis, model, mechanics, and conclusion. So what I'm writing down here should be a pretty much exactly what you should write down for a question like this. So our hypotheses. So before we start, actually, we're going to want to define our variables. Right? Our null hypothesis, the proportion is the same in 2014 as it is in 2017. That is our hypothesis in words. If we want to write this, we should write down what each of those are. So P14 is the proportion resistant in 2014, and P17 will be the proportion resistant in 2017. We are asked if it is increasing, right? So we want to see if 2017 is greater than 2014. All right, those are our hypotheses. The model is where we check to see if we can use that, right? We want to be using a 2-proportion z-test here. The model is where we check if we can. So random. We are told that they are randomly selected. So if I were doing this on this sheet of paper, I'd probably circle those and draw an arrow down, but I'm not, so we're told randomly selected. Let's see now, what else do we need? We need less than 10% of the population. So we're not given a population size, but we are given our 2 sample sizes, 61 and 52. If this is a problem, right, we're told it's becoming a problem. People are concerned about this. If this is a problem, it's reasonable to assume there are more than 600. And I'll just go 610 just to be more specific. it's reasonable to assume there's more than 610 plants, right? If there were only 600 of them, this would not be a problem. There's probably millions. All right, what else do we have? We need 10 successes and 10 failures. All right, so we have a little bit of work to do. So our null hypothesis says that these are proportionate. These are the same proportion. So we're going to use that here for our proportions. So let's see now. What do we have? 19.7. 0.197 times 0.197 times 61 is 12. Okay. And what's the other one? 0.385 times 52 is 20. So we have 32 out of 61 plus 52 is 113. So 28% overall is what we're going to guess. Okay, so we have 0.283 times 61. We have not 1 minus 0.283, whatever that is, times 61. We have 0.283 times 52. We have 1 minus 0.283 times 52. 0.283 times 61. 61 minus that. Okay, so we have 17.3. We have 43.7. 0.283 times 52. We have 14.7, and we have 37.3. You don't need to do all of this, but you do need to do this. You should check and make sure that that's reasonable. Like clearly this is going to be the smallest one. So that's the one that you would actually need to check. But like you do need to do is greater than 10. You need to write that down. Or greater than or equal to 10, whatever. All right. And now these are independent samples. So like as long as we're not checking the same plants, because we're probably not, these things last for a season and then blow away. We have independent samples. So the model we want to use is going to do perform a 2-proportion z-test. And that is our model. For the mechanics, we're turning to the calculator. And let's just do it on here, because I've kind of already typed everything in. All right, well, whatever. Okay, so we're doing a 2-proportion z-test. That is number 6. These, okay, so this 12, we're not given anywhere, but that's 0.197 times 61, and you do that, and you got to change it back to 12. This 20 came from 0.385 times 52, that's 20.2. Got to change that back to 20. All right, so we have our proportions, and our our alternative hypothesis, sorry, is that P1 is less than P2. In this case, 1 is 2014, and 2 is 2017. So we want P1 is less than P2. Calculate. All right. We need to write down all of the things we did not have already. So the z-score, we need to write down the p-value. We need to write down, and our combined p-hat, I mean, we've used that already. But the p1 and p-hat1, p-hat2, those were given in the problem. We don't need to write those down. So let's write all of those down. All right. P-hat combined is 0.283. Our z-score is negative 2.209, and our p-value is 0.01357. And that is mechanics. All right, for our conclusion, I need a separate sheet of paper. With a p-value of 0.01357 is less than 0.05, and use 0.05 here because we're told to use alpha is 0.05 in the problem. We reject the null hypothesis. We have evidence that the proportion of resistant plants has increased from between 2014 and 2017.